So welcome to Calculus. I am Mr. Hopeley, and I will be explaining to you these concepts. So we're in the chapter 1. So today we start chapter 1, which is graphs of functions. So we have a few objectives. We have followed them. Today we want to learn how to sketch graphs. Second thing we want to learn is how to find x and y intercepts. Third thing we want to do is how to use symmetry to sketch graphical equations. The fourth thing we want to do is how to find and graph equations of circles. And lastly, we want to see how to use graphs of equations to solve real-life problems. Those are our 5 objectives. We're going to take this into 2 videos. I'm going to try to cover first 3 objectives in the first video and the last 2 in the second video, but we'll see how time arranges for that. Well, the first thing we want to know is what in the world is a graph? Okay. A graph, in short, is an image. Image of a function or relation. So the idea is that it's a visual, something that you can see, something that shows you different kinds of relationships. So to start off with certain types of graphs, you have a graph like this, and this is called a linear graph. And of course, you guys are familiar with the xy plane by now, the xy coordinate system. These are some examples of what kind of graphs you can see. And over here is a quadratic graph. This is also known as a parabola. Or you can see something, it doesn't matter, it can have any kind of shape that you want. These are just a few common graphs. These are just a few common graphs that you can see. The idea behind the graph is we want to show a relationship between two quantities. So I'll write that on the next page. Here, we want to show a relationship between quantities. Now this can be any kind of quantities that you want. Doesn't matter. From popular graphs, since I teach physics, you have a relationship between time and speed, for example. Or you have a relationship between force and mass, for example. Or the relationship between potential difference and its resistance, for example, something like that. And these are graphs, you can draw something like that. Yeah. But the idea is that we're showing a relationship between two different quantities. Or you can just say between something x, between x or y and x. Okay. Recall that y is the independent variable and x is I have it flipped. So y is dependent upon x. Okay, so recall that all from your algebra class that you took a long time ago, of course. And I'm sure that you all were wide awake during this class and learned a lot about your algebra, and you learned about independent and dependent variables and all this kind of thing. So I'm not going to go over that again here. This is for calculus. At this point, you should know what the difference between independent and dependent variables are. So now that you understand this concept or idea, what I want now to talk about, x is our independent variable and y is a dependent variable. But we don't really need to know about that. So we need to know some things about graphs, right? I told you that a graph is an image. It shows a relationship between two different points. Now, typically we write equations in two variables. When we write an equation in two variables, right, you see here, we have two variables. We have speed, time, force, mass, potential difference, resistance, x, y. It doesn't matter what they are. So it's expressed as an equation in two variables. So to define that for us, an equation in two variables shows the relationship between x and y. I mean, you can name the letters whatever you want, but that's what I mean when we talk about the equation in two variables. And so every equation, so I'm going to give you an example of an equation in two variables real quickly like that. So some example, let's say something like I have y is equal to 2x plus 3. This is an equation in two variables because I have the relationship between y and x. So in this case, what it's telling me is that y will be twice the x value plus 3. And we'll talk more in detail about that in a minute. And every graph has a solution. So as you learned in your algebra and geometry classes from many ages ago, solution is really full answer to a problem. So the solution shows you all steps from beginning to end. So certainly true. Okay. So we call this solution point. Solution point is ordered pair of x and y. An ordered pair x, y that solves an equation. I'll use EQ for equation. Okay. So everybody have an idea of what we're talking about. So a graph is an image. It shows us something. And so for every image, we have to have a function that describes it. Okay. Right, so I'm going to write this down. Those are very important notes. Right, for every image, and we use an upside down A, mathematical lingo, to describe for every. And if I ever get lazy, this is what we'll do. I'll write like that. For every image, there must be an equation that describes it. Okay? And that's a very key point in mathematics. Even if the equation cannot be solved explicitly, meaning in terms of y, but every image that you see has an equation that describes it. You might not always be able to find it, but you can do it. But in this class, we'll always have equations that we can work with. So, as you know, our first objective is to learn how to sketch equations. So this is objective 1. How to sketch equations. So, for example, let's try to draw let's do my example from earlier. Y is equal to 2x plus 3. Okay. How do we do this without knowing anything about the equation? Now, so what we have to do is create a table of values. So that's the first thing that we're going to do, is create a table of values. Okay. So we create a table of values. The values for x are arbitrary. I can make them up. They can be whatever you want. Okay. Yeah. So how do we do that? So we set up a table like this. So I'm just going to do this. X 2x plus 3 and y. Now I'm going to choose some points. Let's say 0, 1, 2. Let's just say 0, 1, and 2. I'll choose 3 points. Okay. like, let's go 0, 1, 2, 3. So 0, 1, 2, 3, 4, 4 points. Although, you want to choose a minimum of 3. Okay? So that's how we create the table of values. The second thing we do is plug x into the equation. Okay, so wherever you see x, you put the numerical value, in this case 0, plus 3, 2 times 0 is 0, plus 3 is 3. Okay? And then, of course, same for the rest, 2 times 1 plus 3, 2 times 1 is 2, plus 3 is 5, okay, so on. You get the picture. You're plugging in numbers. Plus 3 is of course 7. And if you haven't figured out that this is kind of going in a pattern, 6 plus 3 is of course 9. And of course, plus 3, that's 11. So now we create the ordered pairs. And this is, of course, the point plotting method. So creating our list of ordered pairs. So it's going to x, y, x, y, 0, 1, 2, 3, 4, 3, 5, 7, 9, and 11, 0, 3, 1, 5, 2, 7, 3, 9, and 4, 11. So now that we have our table of values, we need to sketch. We need to make the graph. Alright, so let's draw the graph out. So we draw our x and y planes out. So I'm going to go ahead and cheat. And let's find the line, something like this. Let's see if there's something for it. I'm looking for something. Let's see if I can find it. There's the shape. Okay. I can't draw perfectly, so you'll have to deal with it. So we make our graph, the 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're at 0, 3, 1, 2, 3, 1, 5, 1, 2, 4, 5. This is not a perfect graph because I can't draw the line straight. 2, 7, 7, 3, 9, and 4, 11. And you do like that. So recall that this should all be review for us. This is the y-axis and this is the x-axis. You go across on the x-axis and up on the y-axis. Hopefully, hopefully I can find the x and y graph, and this way we can do that better. Okay, so that's an example of a linear graph. Let's try a different one. Let me go back to full screen mode. Let's graph y equals x squared minus 3. The same concept for this problem. We want to have a table of values, and for that table of values, we're going to create the table. And then after we create the table, we will plug numbers in. And of course, lastly, we're going to plot them. So to make our table, we'll do it like this. Now, bear in mind that I'm showing you a little bit of extra work here. This middle column you don't really need. It's just there to kind of help you visualize, make sure you know what to do. Make a table of values. Whenever you see a squared, you're going to want to use some negative numbers. So we're going to use -1, 0, 1, and 2. Okay. Whenever you see a squared or fourth, you're going to want to use some negative numbers because that's going to be a mirrored graph, and I'll show you what this looks like. So I'm going to go ahead and skip this step of just plugging numbers in. -1 squared is 1. 1 subtract 3 is -2. And then when you plug in 0, 0 squared is 0. 0 minus 3 is -3. 1 squared is 1. 1 minus 3 is, of course, -2. And then 2 squared is 4. 4 minus 3 is 1. So our ordered pairs, I'm going to go ahead and put the ordered pairs right here. Again, this is more detailed than necessary. So at -1, -2, 0, -3, 1, -2, 2, 1. Alright? Eventually, I would like to find a graphing tool on here so that I don't have to draw ugly graphs. But for now, you'll have to deal with my drawing. Okay. And so we're going to have -1, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5. Of course, as you know, the x and y graphs goes on forever. Cancel that. 4, 5, 6, 7, 2, 3, 4. Okay. So 1 is -2 right here. 0, -3. So 1, 2, 1, 2, 3 right here. 1, -2, 2, 1. And so it forms a graph like this. Something like that. So it looks like a mirrored graph. So parabola always looks like near, so it's same on one side and same on the other side. Ugh, don't know why that showed up. Go away. Now, so you get the idea here. When we just plug it, we simply take the numbers, we plug the x's into the y. In the equation, we get our y value, then we plot the points, and that's how we make our graph. So nothing too complicated, it's all review from Algebra 1 or Algebra 2. So this is easy enough. So how do we find the x and y intercepts of the graph? Well, first, let's visualize what this is. So let's go on to Objective 2. Why is the application installing? I didn't say anything. Okay, so cancel, cancel. Oh, boy, this is getting on my nerves. Play. Okay, so our second objective is how to find the x and y intercepts of an equation. Okay. Now, to visualize this, okay, here's your y-axis, here's your x-axis. Right. So if I draw a graph, something like this. This is kind of a visualization tool here. Where it crosses the x-axis is called an x-intercept. And then the y-intercept obviously crosses the y-axis. Can't spell, that's okay. Okay, so in this situation, I have a graph. To visualize it, these x-intercept, these two are what we call x-intercepts. This graph right here is what we call a y-intercept. So it intersects the y. Okay. Everybody follow? That's what's going on here? So intercepts are where they cross the axis. So to find the x-intercept, what do I see in the picture? In the picture, the x-intercept is where y is 0. So this is the method. Write it down. Memorize it. Do what you may. So the method for the x-intercept is set y is equal to 0. Solve for x. For the y-intercept, the opposite is true. Set x to 0. Solve for y. Okay. The x-intercept is always a number, comma, 0. The y-intercept is always 0, comma, a number, we'll call it b. Okay? Does that make sense? So let's do that. Okay. So for the same examples that we did earlier, I want to find the x and y intercepts for them. So I want to find x and y intercepts. Exploded modems, yeah. Okay. That looks hideous. Okay? So we have two equations I want to find the x and y intercepts for. So to solve for the x-intercepts in this equation, it's really simple. We just set y to 0. So solution. Okay, so for our x-intercept, okay, our y is equal to 0. So in both equations, we're going to have 0 equals 2x plus 3. And then in my second equation, I will have 0 equals x squared minus 3. And I want to solve each equation for x, so subtract 3, we end up with 2x equals negative 3. In this situation, I want to add 3, add 3. Then I had x squared equals 3. Thusly, divide by 2, x equals 3 halves. In this situation, I have x is equal to plus or minus the square root of 3. Now, question, why is it both positive and negative? The reason why it is positive and negative is, of course, because if you multiply two negative numbers, you get positive number. So you always account for both numbers when you're working with the squared function. So in the first situation, I have plus or minus square root of 3, comma 0. Second situation, I have negative 3 halves, comma 0. They're always a point. Whenever I ask for intercepts, they're always points. So make sure you write it in ordered pair form. So always write in x comma y form. Alright, so it's very important that you remember that the x and y intercepts are points. So they have to be drawn as points. And I will mark them down if you do it otherwise. So these are your x and y. So these are your x intercepts. Okay. It's got a different color out. Okay. And then for the y-intercepts, x equals 0. So if that isn't obvious, plug in 0. Plug in 0, you get the point 0, 3, and 0, negative 3 for the other graph. So that's how we get the x and y intercepts. We just plug in numbers, we plug in our 0 to each one, and then we get the points. Okay. Everybody got it. Hopefully so. Now, something very important for you to recognize, that not all functions will have x-intercept, or not all functions will have y-intercept. And that we'll go into a little bit more detail later. Okay. And I will cover symmetry in next lecture, so I want to shut up now. So now for your homework is to read page 2 through 4. Oops. Oh, you need objectives quiz. So certainly, don't forget that. Okay. Graph the following. And then I want you to find the x and y intercepts for these equations. And then for your homework, you will read page 2 through 4 and 2 page 9 numbers 5 through 20. All of them, please. Okay? So that is all for now. And until next lecture, this is all.